Hey hackers, Sol here from CCS. Welcome back to the channel. Today I'm going to be showing you how to make a headless Raspberry Pi Wardriving rig using some kind of old phone as a GPS system. For this project, you're going to need a Raspberry Pi, as well as all the Raspberry Pi items such as a microSD card reader, and a power source. You're also going to need access to the internet via Ethernet cable. This is to download the necessary packages and get the right IP address for our Raspberry Pi. You're going to need some kind of portable power source for the Pi. I'm using just a usual phone power bank. Just make sure it's powerful enough to support the Pi because you don't want it to fail while you're out in the wild. You're also going to need some kind of Wi-Fi adapter that supports monitor mode. For this tutorial, I'm going to be using this one. You can use any of them as long as they have the right Linux drivers. If you have the same one I do, I'll go over the driver installation in this video, but if you don't, then make sure to check your manufacturer's website for the correct Linux drivers. Of course, you're also going to need some kind of Android or iPhone for your GPS. And iPhone is going to be a little bit limited because the app that we're using has a paid and a light version. The light version only allows you to transmit GPS data for 4 minutes, but you can just toggle it off and on, and that'll just work fine. The Android app can transmit GPS data indefinitely, so Android is preferred, but iPhone will also work. Keep in mind that you do not need any kind of SIM card or mobile data to have this work. While you do need it for something like Google Maps, normal GPS data actually doesn't require this, so you can just you don't need any kind of internet connection to have this work. So without further ado, let's get into the infrastructure of how we are going to set this up. Alright, so now that we have all our requirements, we're going to go ahead and explain the infrastructure of our project. So we're going to have our Pi work as the AP or access point, which is going to be the thing that our devices are connecting off of, your phone, your laptop, anything that needs to access the Pi is going to be on this net. We're also going to use this secondary adapter for monitor mode and Kismet, and the power bank for power. Make sure it is connected to your router at wherever you are, so it can get internet, so we can install the necessary packages and tools. Alright, so now that we have all of that stuff done, we're going to actually start on the project. So we're going to be using the Raspberry Pi Imager for this, and we're going to be using the Raspberry Pi Lite 64-bit operating system. The Raspberry Pi 32-bit Lite will also work, but mine is a Raspberry Pi 4, so it just kind of depends on the Pi that you're using. 64-bit will work, 32-bit will work. Just make sure it's light because we don't need a desktop environment for this. And for storage, make sure you choose your SD card that you have plugged into your machine because you don't want to overwrite some kind of important disk. You don't want to overwrite your main disk because that would be bad. We're also going to come down to the settings cog and set a host name if you want. You don't need this, but it'll be Pi by default. I'm setting it to Beach Thing because I like Death Stranding, but that's up to you. You can also enable SSH, which is how we're going to access this. Set a username and password, and also set your locale. Just hit save, and then just hit write, and it will start writing. And once you authenticate, we will be back after it's finished. At this point, you can plug in your Pi and boot it up and plug in your Ethernet cable and get connected to the Wi-Fi, and then we're going to go over how to get your IP address as well. Okay, so now that we have our IP address, which is easiest to get by going to your router's web page, your local web page, the easiest way to find the IP address of your router is the command iproute. But you can do that, and it'll probably be listed here with your hostname that you set. Here's my Raspberry Pi's IP here. But if this doesn't work, you can also use the command arpscan and scan your local net. And there will be a whole bunch of devices, and if some of them say unknown, you can just copy the MAC address and go to MAC address lookup page like this and just paste it in, and it'll tell you that it is a Raspberry Pi device because MAC addresses are vendor specific. So, you know, you can tell it's a Raspberry Pi device based on the MAC address. Okay, so now that we have the IP address for that, we can actually get into the machine, which is awesome. So the command we're going to use for this is just going to be SSH your username at the IP address that you have for your Pi. We're going to accept all fingerprints, and we're going to enter in our password as well. Now that we are in our Raspberry Pi, we can actually start configuring things. So the first thing we're going to do is going to be to update the system with sudo apt update. It's pretty standard if you guys have done any projects, which I hope you have, because this one's a little bit more complicated. But, you know, just standard stuff. apt is obviously our package manager for Debian systems, which Raspberry Pi OS is based off of. So now what we're going to do is install the basic tools that we need. So we're going to need a couple of different things. We're going to need Hostapd, so for our access point. We're going to need DNSMasq, and we're going to need GPSD, I think it's clients. Yeah. So I'm kind of an idiot, and I forgot to mention that you should also install Netcat. Oops. Yeah. And Kismet, but we'll have to install Kismet separately because it's not part of the Raspberry Pi repositories. Okay, now that those are installed, we can install Kismet, and we're going, because this tool is not in the normal Raspbian repositories, we're gonna have to add a third-party one. So we're gonna enter in this command here. I'll leave all these commands in the description below, but basically we're just getting the GPG key, which is used to sign the repositories, make sure all the packages are, you know, not tampered with, all safe. So we're going to do that. Okay, and once that is done, we're going to enter in this command, which is going to add the Kismet repository to our sources.list, which is basically the list of repositories that apt can basically get tools and stuff from. So that's just going to be pretty fast and simple. We are going to do another sudo apt update. And then finally, we're just going to run sudo apt install Kismet for Kismet. And if you get this error, it's okay to fix. We just have to clone this package because we don't have this installed. The current version is going to be this one here. We're getting the ARM64 version because the Raspberry Pi is a ARM-based device, is not a, you know, standard AMD 64-based device. So it's going to be an ARM processor. So we got to make sure we grab the right architecture. Make sure you grab the right version as well. And we're just going to download that, and we are going to install it as well, just like that. And now we can actually install Kismet because our dependencies are fixed. And for this, we can just enter, I'm just going to put yes as the default. It kind of depends on what you want. Okay, so now that we have our tools installed, we need to configure the interface name. Now we want to do this because I've had some problems where if you don't do this, it'll try and use the wrong interface. So we want to make sure that we're using the right one, and to do this, we're going to give it a name. So first step is to get the MAC address of the interface we're going to use. So if we type in IP link, we can get a list of all the interfaces available on our device. So we have LO, Ethernet 0, and WLAN 0. So these two are going to not be important. This one's our Ethernet cable, which is not important to us, and this one's our loopback, which is also not important to us. The only one we're going to be concerned about is this one, the WLAN 0. This stands for wireless, and it's going to be the wireless access point interface. So we need to make a note of this MAC address. It's not going to be the same. Yours is going to be different. It might even have a different name. Just make sure you're choosing the right one. Search up the MAC address if you have any concerns that you're not choosing the right one, and you can get some information that way. So we're going to make a note of this. You can copy this, but we're actually probably going to have to copy and paste something in a second anyways, so that's okay. So the next thing we're going to do is get this file in etc udev rules, and we're going to make this file called 70persistent-net.rules. So this is going to be the file that's going to be the config for this device. So as always, all this stuff is going to be in the description, so you can just copy and paste. But I'll walk you through it. This is going to be the thing we're going to enter in here, and where it says here, where it says address, we're going to change whatever is in these two little quotation marks. We're going to change this to the MAC address of the wireless card. So if we want to copy and paste this again, we can go back into this file, and then we can just paste it in here like that. And none of this other stuff is important except this part at the name at the end, which is actually, this is also important. We're going to change this to WLAN because it's a wireless device and not an Ethernet device. And we're just going to change this name. You can change it to whatever you want. I'm changing it to WAP0 for wireless access point 0. But it can honestly be whatever you want. So we're just going to hit X and Y to save. And so that is done. Okay, so now that that is configured, we're going to have to configure our DHCP config. So with that, we're just going to enter in this command. It should look like this. Make sure you're adding the CD, because I sometimes forget and forget the C because I think it's just D. So just make sure you do that. Make sure you're editing the right file. So now we can just scroll to the bottom, and we're going to put in these settings. So we're going to have our interface as our wireless access point 0. This is going to be the name of whatever you configured in the last step. You're going to set your static IP address for the router. This is what is going to be what we will SSH to when we're actually on the wireless network. Make sure you add your subnet mask as well, so we can save that. So now we're going to have to set up DNSMasq, and we're going to, okay, so first we're going to want to back it up just in case. So we're going to copy, I think it's etc, DNSMasq.conf, and we're just going to put that in etc DNSMasq.conf, and we're just going to name that with .backup. So now that that's backed up, we can edit the main file itself. And all we have to add is this config over here, where we define our interface as access point 0. We define our range of IP addresses, so it's going to be from this to this. Depends on whatever your last step is. Make sure the IP address of the router is not in this range, otherwise it will cause some issues. and then we're just telling it that it can reset every 24 hours. It's going to be in the wireless domain, and so we just need to save that, and that's done. Okay, so now that that's done, all we have to do is configure Hostapd, which is going to be the thing that is hosting our access point. So first we want to enter in sudo systemctl unmask, I think, because unmask hostapd, because by default it is masked. And so then we also want to enable it, which is going to start it on boot. And then we want to edit the etc hostapd hostapd.conf, I think it is. Hostapd.conf, yes. And then we just want to paste in all this information. So country code, this depends on where you are. I'll leave a command up on the screen for how to find this out. Your interface is just going to be the same thing we've been figuring this entire time. The SSID is going to be the name of the Wi-Fi network. So for me, I'm going with the Death Stranding thing. I'm just naming it Carl Network. All this stuff isn't important. Here is your password for the access point. Obviously, don't make a password, but this is just an example. So you can make that whatever you need it to be. And then we just need to save it. Okay, so now that all of our basic configuration is done, we need to install the drivers for the wireless adapter they're using. Now these steps are not going to be the same depending on your adapter. I went over my adapter earlier, so if you have the same one as me, then this will work just fine. If you don't, make sure to visit your manufacturer's website and search for the Linux drivers. Your interface has to be able to be used in monitor mode, so make sure that is all working great. So all we have to do is just copy and paste these commands. It's going to just install some headers, and we're going to need to compile the drivers ourselves, which can take a little bit, but it only took me about, I think, 5 minutes when I was doing this. So I'm going to install the headers, yes, and we're going to want to clone this repository, which is going to be where we are getting the drivers from. Okay, so now that that's done, we just can clone. Oh, I guess we don't have Git installed, which is interesting. It's okay though, we can just install Git. Huh. I guess when it meant light, it really was light, so let's install Git then. Okay, and now we can clone the drivers. Okay, and now we cd into that directory, and then we compile them, and then we install them. Okay, done compiling and installing, and we're ready for the next step. Alright, congratulations! All the configurations are done, and now our Wi-Fi access point should be working. So, there's only two things we need to do. The first is we need to enter in this command to unblock the Wi-Fi. So we're going to do that. And the second command is going to be to enable hostapd. And now it should work on boot. So when your Raspberry Pi boots up, it should automatically enable hostapd. You can also manually enable it with this command, and then you can verify that it is enabled using this command. And you can see that it is active and running. And actually, if you open your phone or some kind of network, you'll actually see that your access point is running, and you can actually connect to it with the password that you set. So that's all done. And so now all we have to do is get our phone for GPS set up, we got to set up Kismet, and we're done. This is pretty much the hardest part. So we're going to do that now. Okay, so at this point, you're going to want to reboot your Raspberry Pi, unplug it from the Ethernet cable that you have, and connect your device that you're using to SSH into it to its network. It'll be called whatever you named it, so make sure you have it connected to that. Next thing you're going to do is you're going to want to SSH into the machine, and the IP address is going to be changed because we're connecting on its own network. We're not connecting over your local network. We're actually connecting to the Pi directly, as it is also our router at this time. So you're going to want to SSH into whatever IP you set to be the static IP for the router. And we're going to want to log in. This is great. So we're logged in now. We're connected over its own Wi-Fi, so we're not on the local network anymore. Now the only problem with this is that we're not going to have any internet now for the remainder of this. That's okay because we already installed everything we need and configured everything we need. So now that that's done, we just have to basically plug in our wireless adapter. And if you did this correctly, you should be able to type in IP link and see that your wireless access point is enabled and being used. And then you also have the addition of a new wireless interface, which is going to be the Wi-Fi adapter that you just plugged into your Raspberry Pi. And this is going to be the one that we're using for monitor mode. So congratulations, everything's basically all set up great now. So now all we have to do is set up our phones to transmit our GPS data to the interface. Okay, now that we have everything set up, we can actually start working with the GPS data. So I'm going to go over iPhone first, and then I'll go over Android. So the first thing we want to do is type in netcat-ul for UDP and listening. And we're going to be listening on port 9999. It doesn't have to be 9999, but you can choose whatever port you want. And this is going to verify that we're receiving the GPS UDP data. So now on our iPhone, we're going to want to navigate to this app called GPS to IP Lite. If you want to get the full version, it's just GPS to IP. This Lite version is going to be a little bit limited in terms of time, but that's okay. Make sure that you're connected to your Raspberry Pi network. It'll say no internet connection, but that's okay. As long as it's connected, then it's fine. And we're going to go to GPS to IP Lite, and we're going to go to Settings. Now we're going to scroll down and go to Connection Method and click on UDP, and then we're going to edit these settings. So the IP address is going to be the IP address of your router. Similarly, how you SSH'd into your Pi, this is going to be the same IP address, and the port number is going to be the port number that we're listening on. In this case, it is 9999. So once we hit done, make sure it's on UDP push, because GPS is UDP data, and we're just going to enable and allow. And now you can see that we're actually receiving GPS data from Netcat. So this is confirming that the data is going through and actually getting to our machine. So that's awesome. Everything is working as intended. So now all we can do, we just need to quit Netcat. We can clear the screen. Okay, so now all we have to do is go to /etsy/kismet/kismet.conf, and we have to edit this Kismet config file, and all we have to do is add in this line. I already have it here, but you're going to need to copy paste this in, which is basically telling Kismet to use the GPS data that we are going to provide instead of some kind of other GPS dongle or anything like that. So now that this is done, we can enable our GPS on our phone, and we can listen on that port for data. And then we can start up Kismet with this command. You can see that we did get a response from this side, which means the client did actually connect. So now all we have to do is navigate to 192.168. It's actually already here. You want to go to the IP address of your machine, of your Raspberry Pi, and then the port number. And this is going to give us our Kismet overview. It's going to prompt you for a password and a username, but as long as you provide that, it should be all good. Make sure that your phone is connected on the right Wi-Fi network. And there we go. Now we're getting GPS data. Obviously, this is all going to be censored, but as long as you can, the GPS data will be up here. So, yeah. So that's it. I'll go over how to do the same thing on an Android, but it's pretty much the same process, just with a different app. Now, unfortunately, I do not have an Android phone I can actually screen record on and show you guys this, but the app you're going to download is called GPSD Client, okay? And it looks like this, and the interface is going to be super simple. Basically, you're just going to type in the IP address of your Raspberry Pi up here. Make sure your Android phone is connected to Wi-Fi. So type in your IP address, type in the port number that you're listening on. You can review the same instructions for iPhone because it's basically the same, but for me I put it as 9999, and make sure you have the right IP, and then you can just hit start, and it'll start sending that data over to Kismet, and then you can verify that you're getting it with this command. Okay, so I want to add just two things that will make the experience better for you. When you are using Kismet and GPSD, you can actually enable the --daemonize flag for Kismet, and this will actually run it in the background. So we can actually close the terminal and have it still run. And then we can do the same thing with GPSD by removing the -N that we had earlier. So before it was like this, and we just get rid of that, and it'll also run as a daemon. We also have to run it with sudo. Yeah, so we can run both those in the background. And if you're having any trouble getting GPSD to start, there are two things you can try. The first is to stop the actual GPSD service with this command. And if that doesn't work, then you can also pkill it with pkill GPSD, and this will kill any GPSD services running. So sometimes it won't let you launch it if there's two different ones running, but this should fix it. Alright, thanks for watching this video. I apologize if I was a little bit shaky on this. This is my first time doing it, so I hope you enjoyed the video. I hope it worked well for you. If it didn't, feel free to let me know in the comments below. You can also message me on Discord. I will have a link to the CCS Discord server in the description. You can hop on there, just let me know if something is wrong, if I did something wrong, and I will try and fix it. So, thanks for watching, and happy hacking.